Okay, let's start with chapter 4. There aren't many notes for chapter 4. As I said, it's a lot of just graphing two equations at the same time instead of one. But first, you really got to understand what a system of equations is and what a system solution is. So, and 4.2 and 4.3 are all going to be solving the exact same types of problems, no exceptions. The only difference is each of the three sections is a different method to solve systems of equations. So first, a system of equations is just two or more equations. We are only going to be dealing with two. When you go to Math 263, you'll be dealing with three equations. But two or more equations put together in one system. Now, the key part of this is what does a solution to this look like? So first, let's take an example. Okay, so an example would be number 1 in your book. Here's the system. We use an open set notation bracket here, as in these two things are together in one set, in one system, and 2x plus 3y equals -5, 7x minus 3y equals 23. So that's what a system looks like, okay? It's a system of two equations together with this set notation here, okay? Now, what does it mean for something to be a solution to a system of equations?
If you plug in the answer to the equation, it'll be on the plot or the graph or the line
Yeah.
where they cross.
Yeah, so that's even a bigger idea. But yeah, in general, the first thing you said is just what does it mean for anything to be a solution of anything? It means when I plug it in, it's true, right? That's it. And so a solution to this is no different. So there are x's and y's here. So my solution has to be a point because I have to plug a number in for x and plug a number in for y. So a solution to this system is an ordered pair or a point. Those are the same thing, ordered pair slash point that I can plug in to both equations, and it makes both true. Okay, that important part is that it's both equations. Okay, really common mistake is somebody just plugging it into the first one and saying, yeah, it works, done. Okay, these are two separate equations. You need to plug your point into the first one and say, does it work in that one? Yeah. Does it work in that one? Yeah. Now it for sure is a solution to the system of equations. So let's just do two quick examples of that before we move on to how to solve them. So first question on your homework is going to be, is it a solution? Okay, so number 2. Is this point a solution to the system of equations? Okay, it gives you the point -2, -5, and it gives you the system 6x minus 2y is -2. 3x plus y is -11. So, is it a solution? Okay. Real simple, straightforward directions. Plug it in to both. That's it. If you want to know if it's a solution, you plug it into both. Okay, so the first one, 6 times negative 2 minus 2 times negative 5, is that negative 2? Negative 12 minus negative 10, whoa, I wrote 16. Negative 12 plus 10, that's negative 2 equals negative 2. Check. Plug it into the second one. 3 times negative 2 plus negative 5 equals negative 11. Negative 6 plus negative 5 is negative 11. So yeah, negative 11 is negative 11. So it worked in both equations. So then I would say yes, it is a solution to both. Okay, but it's either yes or no. It either works in both equations or it is not a solution. Okay, so similar problem. Number 10, same question, except different point, different equations. 5 negative 2 with the equations 4x minus 3y equals 26, and x equals 15 minus 5y. Okay, so you plug it into both. Plug it into the first one. 4 times 5 minus 3 times negative 2. So that's 20 minus negative 6, which is 20 plus 6, or 26 equals 26. So it works. Don't stop there. You're not done, right? Too often people are like, oh yeah, okay, it's a solution. Let's plug it into the second one and see. So 5 equals 15 minus 5 times negative 2. That's 15 minus negative 10. 15 plus 10, which is 25, is equal to 5. Not true. Okay, so the answer to this would be?
Yes.
Yeah, it's not a solution. It doesn't matter that it satisfies one. Is it a solution to the entire system of equations? No. Okay. All right. So that's the first and most important thing of all of chapter 4. Because all of chapter 4, it's 4 sections long, is all about solving systems of equations. So if you don't know that the answer to a system of equations is a point, right, that's a huge thing you're missing, and you're going to get every problem wrong. So first and foremost, you need to understand, when I've got 2 variables and 2 equations, your answer is a point, an x comma y, that I can plug into both, and it makes both true. Okay. Later on in Math 363, you'll get 3 equations with 3 variables. Okay. And what we're going to do is we're going to attack this with graphing in this section. And then with section 2, we're going to do substitution. With section 3, we're going to do elimination. And then with section 4, it's going to be word problems, and you can choose whichever method you want. You could graph it, you could, et cetera, et cetera. All right. So let's look at the next thing. How do we solve it by graphing? Okay. So graphically, in terms of a graph, a system is 2 lines on one graph. A solution, and when I say system, I mean a system of equations. Okay? And a solution is a point that lies on both lines. Usually there's only one point, right? Sometimes there's more or less. So we'll just say it's a point. Okay. And big, there are 3 possible cases or scenarios. Okay, let's look it up. Okay, so here are 3 cases. Here's case number 1. Okay, case number 1 by far is the most common, probably making up about 90% of all the problems we're going to solve. And that is, on one graph, you have, let me just get two colors here. You have two different lines. Okay. The key being these have, the lines have different slopes. So as long as the lines have different slopes, how many solutions are there?
One.
Yeah, there's one solution. So the solution, right? There is one solution. And don't feel like afraid ever to, come out with answers, even if they're not right. That's the learning process. I prefer a multitude of voices to silence.
What if there is no intersection?
Whoa, that might be case number 2. Okay? So,
There's no intersection.
case number 2 is okay. Right. In this scenario B, the lines are parallel, but they're not the same line. Okay, so just two parallel lines. So how many times will they cross? How many solutions are there? 0. Yeah, no solutions. Right, so there's no point that lies on both lines. Never. I mean, that's kind of the definition of parallel lines, is they never intersect, so there is no point that is ever on both lines. Alright? And finally, case 3. Is a little harder to draw, but the idea being that your two lines are not only parallel, they're exactly the same line. Okay, so this time the two lines are parallel and are actually the same line. Right, so how many solutions are there to this? Yeah, many, many, many. Infinitely many.
Oh, you're right, but just.
Ah, good question. So infinitely many solutions. And I'm gonna write in parentheses really quick. I know this is kind of low, so maybe not everybody can see. Any point on one line is necessarily on the second line. Okay, so that's part 1. Part 2, I'll write up here because it's harder to express down there. But there are not all real numbers, so there's a difference here. So the answer to case 3 or all solutions or any solutions for 2 big reasons. 1, we're not talking about numbers here, we're talking about points. So we're talking about an ordered pair of 2 points, that's one reason. Okay. Second reason being, solutions are points on the line. Okay, so there are infinitely many, but there are also infinitely many points not on the line too. So in general, you would just say there are infinitely many solutions. That's it. okay? And that will be as far as you go. But that's a big question that people in the past in my classes have struggled with, is how can there be infinitely many yet it's not all, right? And the idea is I can swing my pen and say, is this a solution? No. Is this a solution? Yeah. This one?
Yes.
Yeah. So I can move my pen around, and there's infinitely many out there that are not on the line, but at the same time, there's infinitely many that are on the line. So you would just say there are infinitely many solutions. And there are only 3 cases. Most always, you're looking for one place where they cross. If they are parallel, all you need to say is, they're not the same line, so there's no solution. Or, they are the same line, so there's infinitely many solutions. So you would write no solution or infinitely many solutions. Yeah.
Is another correct way to express that, like, basically all real numbers such that it makes the equation true?
Yeah, and if you were to write it, the way you would actually write it in math, which is kind of convoluted, we're not going to do this in this class, but you would write a set notation, and you would say all the points x, y, and then this bar means such that. So you'd say all the points such that, and then you would write the equation of the line. So in other
Just use
words,
x, y, you wouldn't use like all real numbers or anything like that, it would just be x, y.
I mean, that's what you'd say, or you could even say all x, y existing in, and then you could say that, but no, you just say all the x, y such that, because we're assuming it's real numbers in this course. And again, you would never ever need this in this class, but you could say all the x, y such that, and basically what you're saying is the point is on the line.
Right.
But we don't need to do this in this class, maybe depending on the teacher, 263, you might do that, but you guys are good teachers this fall for 263 here. Mr. Washburn and Bishop, I hear both are really good. Okay, yeah, okay, so that's it. Now all you're gonna do is solve some systems by graphing, so let's do one together and let you guys go. The way I'm actually gonna do it, I'm gonna cover this up really quick, which are hard, but what I'm gonna do is I'm actually gonna turn on Khan Academy really quick, because they have cool graphs that look awesome. There we go, okay. Alright. Let's turn this on. Kathleen, can you get those lights back there? Thank you. Okay.
What Graphical instead, perfect too.
Okay, so, let's see, so let's just check this answer. Let's go.
Stupid.
One, two. Yeah, right. Oh, okay, it's already up. Alright, not letting me. Oh, yeah, okay. Just wanna reset this, so we got them all wrong. Let's go check. No dang, okay, so, when you go to Khan Academy, I just, I put the links all on the class website, so when you go to the class website, you can see there's links to all these Khan Academy things. So I just want to show you that one more time. So as you go to our class, link right here. Right up here, the videos and the notes, here's the homework assignments, and then there's this schedule of all the classes. And so right now, we're on Tuesday, June 30th here. And so what it says is, we're going over 4.1 and 4.2. So here's 4.1. An introduction to systems of linear equations, which we were talking about, like, is it a solution? That's the basic first question. And then it starts, can you solve them? Whoops, can you solve them by graphing? So if you click on this link, up comes these Khan Academy sections. So you've got 2 videos, followed by some questions. Okay? Up at top, it says you need to get 3 in a row correct. So scroll down, and you can solve these problems, and it's got this nice interactive graph. The beauty of this is, if you need a hint, you click on I'd like a hint, you're stuck, watch the video, but it just generates a bunch of practice problems for you to do, okay? And what we're gonna be doing on all of these is graphing two equations to find where they intersect. That's the entire section of 4.1. The one loophole is if they never intersect, or if they're the same line, okay? But 90% of the time, you've just got two lines and you see where they cross. So, for the first equation, how would we graph that? Negative 15x minus 15y equals 45.
I like to put it in the y equals nxb form.
Yeah, me too, let's do it.
form, And then just graph it,
Well, wait, don't get ahead of ourselves. How do we put it in that form?
solve for y.
Yeah, but how do we do that?
You put a point in.
We could put a point in, so you could absolutely do t-chart. You could just plug in x, get y, plug in x
over.
y. But let's do this. Yeah?
Plus 15x.
Yeah, so let's add 15x to both sides. Okay, I'll always write my x's first. So I have negative 5y equals 15x plus 45, and then,
Divide by negative 5.
yeah, divide everything by negative 5. Okay, and you can copy down this exact question as your example in your notes. Equals negative 3x plus negative 9 or minus 9. Okay, so where are we gonna go on the graph?
You can start at
Minus
negative 9
9.
on the y.
Yep, we're gonna start with negative 9 on the y, doesn't matter which line I grab, I'll grab the first one. So I'm gonna go down to, I'm gonna have to scroll down a little bit. So I'm gonna go down to negative 9, and then where am I gonna go from there?
You're going to go,
Plus, slope is negative
3 over 1.
So let's see, so m is negative 3, I'm always gonna write that in two fractions, so that's either,
Negative 3 over 1 or minus 1 over 3.
Or
Yeah.
plus.
or positive 3 over negative. Okay, so one of those two, so where am I going?
Backwards.
Go up 3.
You guys are jumbling, so John, help me out.
Okay,
Where
you're
am I
gonna
going?
go up 3 and over and to the left 1.
Okay, so from that point, I go up 3, left 1. I could have gone down 3, but that
Draw
would have
the
been off my graph, so yeah. So up 3, left 1. So there's my line. Okay, now we got a totally separate second line. Let me scroll up a little bit, so we're back to the original equation. Okay, so what's that second line? Sarah, help me out. How would we graph that one?
Move the 2x to the other side.
And how would we move it?
Plus 2x.
Yeah, so we add 2x, so we get 6y equals 2x plus 6, then
Divide by 2.
we could divide by 2, but it's 6y, so we want to get y by
Oh,
itself.
oh yeah, divide by 6.
Yeah, divide by 6, divide by 6, divide by 6. So that's y equals, you can pull all these numbers out front of your coefficients, so 2/6 is the same as 1/3, and then plus 1. So how would we write that slope? Either as,
1/3.
so positive 1 over positive 3, or,
Negative 1 over negative 3.
yeah, exactly. Okay, so Sarah, tell me how we would graph that.
Put the y-intercept at 1.
Okay, so we'd start at the y-intercept of 1, and then where would we go?
And then move the other guy up 1
Up 1,
and to the right 3.
up 1 and to the right 3, or down 1 and left 3. Okay, so there we go, so we graphed our two lines. So what is the solution to this system? We just solved it by graphing.
Minus 3,
It's gonna be negative
Or negative 0, 0.
Yeah, it's a point. The point is negative 3 comma 0. That's what you put a box around. That's your answer. That's what you're looking for. You're looking for, the whole point of this section is you graph two lines and the answer is the point where they cross.
That's
And
where
let's
it
just
wants
double
us.
check. Let's just double check, okay? Let's plug in negative 3 comma 0 up here. Negative 15 times negative 3, that's positive 45. Minus 0, hey, that's positive 45. For sure that point is on the first line. Okay, let's check if it's also on the second line. Negative 2 times negative 3 is 0. Oh, that's not 0. That's 6
6.
plus 0. is equal to 6. It works in the second one, so for sure, negative 3 comma 0 is our answer. So I go here to Khan Academy. It asks me, what is your x coordinate? Oh, the x coordinate is negative 3. And what is your y coordinate at that point? It's 0. And so we go up here and we go check our answer, and boom, it gives me a little smiley face, and we click to go to the next question. Okay? This one says, approximate the solution to the system of equations. So no arithmetic needed. How would we approximate the solution? Somebody I haven't heard from, maybe Zach. What would be the solution to the system of equations? Around. Doesn't even give us equations, just gives us the graph.
Like the point that they cross at,
Yeah, exactly.
negative 3 3/4 maybe.
Well, this would be positive, and this is the
Or,
y
yeah,
would be.
okay. Yeah, so 3 3/4.
Okay,
Then negative like 5.5-ish.
yeah, sounds good, so let's do it. So let's put in, x is about 3.75, y is about, what did you say?
5.5.
Negative 5.5, there we go. Smiley, we got it, we're awesome. And then, let's do the next one, and oh my gosh, it's already y equals mx plus b. It's asking us for 3 in a row, let's just try it anyways. So, how will we graph those two lines, if they're already there? So Jacob, could you help me with the first one? How will we graph that first one? So it's negative x plus 3. So help me out, what's the slope if it's negative x plus 3? Yeah, so negative 1. How would we write the slope of negative 1? Bless you, in terms of instructions. Yeah, so negative 1 over 1, but hold on, Jacob's helping me. Or, yeah, 1 over. Well, one of them would have to be negative. So either the top one's negative or the bottom one's negative. Okay, so where am I going from our y-intercept? We start at 3, and then where we go? Up 1, which way 1?
Right.
If we went up 1, right 1, that'd be positive 1 over positive 1. So one of them has to be negative. So we can follow either of those instructions. Yeah, so you could go up 1, positive 1, and then left negative 1, and there's a slope of negative 1. Okay? So somebody else, so somebody I haven't heard from, let's go Neil, help me out with the second one. So we got negative 4x minus 6. What's the slope of that one?
Negative 4.
Negative 4. So we got m equals negative 4. Let's write that as a fraction, 2 ways.
So that would be negative 4 over positive.
Yeah.
And
Or-
positive 4 over negative 1.
Okay, so how will we graph this one?
The base on that would be negative 6.
Okay, so we start at negative 6, and then,
And then from there, you would go, for this turn, you could go up 4, and then to the left 1.
so up 4 to the left of 1. Okay, there we go. So let's see where they cross. Where did they cross?
Negative 3, 6.
Yeah, so negative 3 comma 6. You could absolutely plug that in, but you need to know that's what we're searching for. We're searching for the point they cross. All the graphing is just scratch work. Okay, so you graph it, you find they cross there. We could plug that in. Let's do it. Negative 3 would be 3. Plus 3 is 6. So yeah, it checks out. First point works. Okay, let's check the second equation. Negative 4 times negative 3 will be positive 12. Minus 6, positive 12 minus 6, that is 6. So we're sure it works on both. So let's plug it in. So we got negative 3 for our x coordinate, and we got 6 for our y coordinate, and we go check answer. Smiley face, we're amazing. It's giving us all these things, and I'm just going to plug in this last one. And it'll say just, you know, you got them all right, you didn't, and it just generates as many problems as you want. So I chose to do this rather than graphing on the board, because then I'm just making up numbers and it's hard to see. So I would say the difficulty that people will have on this, or one, is if you're graphing on lined paper, it is hard to see where they intersect. So I would really encourage you to use graph paper if possible. All right, so let's break, work on this for like 20 minutes, half hour, and then sometime around 1 we'll switch gears and start 4.2. If people are struggling though, we can absolutely stop and spend more time on this. Okay.
Alright.